Hi, this is Ben, and this will be a video formatted version of how to create the top-down shooter that I did in class. By the end of this, you will be able to create a Vampire Survivor style game with very limited assets along with code. So this should hopefully be beginner friendly for the most part. Alright, let's get into this. Since this is a light demo, we'll only be using 2D Core instead of URP because we won't be using any actual post-processing that comes with URP. First thing you want to do once you've opened up your Unity project is download the textures from the itch.io page. And then to keep this thing organized, we're going to go into Project, Create, New Folder, and then we're going to name that new folder Textures so we can have a spot to place those textures that we're importing. Now that we have our assets in the Unity project, there's a couple things we're going to need to do. One of the first things, since this is a multiple tile image, we're going to need to switch sprite mode to multiple. And this unit size for these pixels is 16 by 16. So all you got to do is for pixels per unit is type 16. And then since Unity does compression, we're going to need to uncompress it by doing point no filter for filter mode, along with compression quality to none. So it won't compress it at all. And then you need to hit apply changes for this to go through. With that done, we can now start separating our sprites by opening Sprite Editor and then clicking and dragging to create the box for your sprites. The main reason why these tile sprites here have an extra bit of pixels that we're not using is that Unity sometimes goes past these points. It's called pixel bleeding, and you'll sometimes get random lines within your tiles if you don't have it like this. You don't have to do this with PNGs obviously because there's supposed to be blank spaces there. Once you're all done, make sure to hit apply before leaving the sprite editor. You now close this, and then you have to hit apply on the texture once again to make changes go through. With our sprites now separated, we can start working on the background for our game. To do this, we need to go into sample scene or your hierarchy, right click, create 2D object, tile map, rectangular tile map. We now have a grid with a one tile map thing. That's all we need to do. Alright, next we're going to create a rule tile for our background sprites. But you do this by clicking in the project, textures, create, 2D, tiles, rule tile. And you can name it whatever. After selecting your rule tile, you can then create a new rule tile. Select one of your sprites, drag it into the sprite box, switch output to random. You can now have multiple sprites. Let's do 3 for size, and drag the rest of your sprites into this area. To place the rule tile, we're going to need to create a tile palette. To do that, you got to go to Window, 2D, Tile Palette. Once you have that open, you can then click on No Valid Palette, create new palette, give it a name if you want, press Create. Then you'll get this window that pops up. This is just asking you where you want to put your tile palette, and just select Folder for Textures. Once that's done, click and drag your background into the tile palette. And then, once you have that done, you can click on the purple circle, press U, and then click and drag to get your background. You can mess around with the rule tile's noise settings with this slider right here, and it will change automatically. We can get our player into scene now by just dragging and dropping the sprite, and now we have a player object that we can work with. I'm just going to center him on 0, 0. And we can now start doing some player movement. We can do this by doing add component, and we can just type it out, player movement, and we can get new script. Just call create and add. Once the script is done compiling, we can then double click on player movement, and it should open Visual Studio Code. To get our player moving, we're going to need to create one global variable, which we'll call it speed, and it is public float speed, and we'll set it to be equal to 4f. You need f for float variables. And then we're going to do this inside a Unity's fixed update. And then we're going to do vector 2, let's call this just motion. And we're going to set it equal to a new vector 2. And we're going to use Unity's input system get raw access. For the x coordinates, we'll do horizontal, and then comma input get raw access vertical for y. And this will give us our basic inputs for that will use WASD and the arrow keys by default. We can then apply this to our transform dot translate motion times our speed times time dot delta time. That will give us our basic motion. We can save this, head back to Unity, let it compile, and then when we run the game, you'll see we have basic motion for our character. One thing you'll notice when doing this is if you go diagonal, you'll move faster than if you were going just straight up, down, left, right. To fix this, we can head back to our script, and at motion, we do dot normalized. Save that, head back to Unity, press play again. You'll notice now we're moving at the same speed no matter what direction we're going. Learn more about Get Access Raw or Unity's input system. We can go to Edit, Project Settings, then you go to Input Manager, drop down for Axis, and these are all the pre-made inputs that you have. This is the ones we just used right here. You can see right, left for arrow keys. And then while we're here, let's also update Fire1 from left control to space. That will be used for later. Keep this demo short. All we're going to do for the camera to make it follow the player is child it to the player object. That way when you start playing the game, it will just follow you around no matter what. And we don't have to worry about creating a camera movement system. While we're here, let's also increase the view distance of the camera by doing size to, let's do 8. That way we can see a little bit further out. Let's quickly set up the enemy by dragging and dropping him into the scene. We got to give him a hitbox, so we'll just give him a basic 2D capsule collider. We can leave that as it is. And let's give him a little script real quick. And let's call it enemy for now. For the script, we're going to give it a target variable or a transform. We're taking the player's transform. So transform, we'll name it target. Then in the start, when it spawns in, we'll have it set target equal to find object by type, and we'll use the player script as its target defined, player movement script, and then we'll do dot transform, and then it will set the transform of target equal to the player. And then we'll give it a fixed update. And in the fixed update, we'll do transform.position equals vector 2 dot move towards. You have to use the current enemy's position, then do target dot position, and then in the global variables we'll add a public float speed equals do 3.5 for its speed. And then here we'll do speed times time dot delta time. And that will have the enemy move towards the player. Let's save this and run this in Unity. You'll see that it now follows the player. It's going a little fast, so we will go here and change the speed. Let's go 3. There we go. That's more doable. Okay, now with that set up, let's start working on our bullet sprite. We can go back to scene view, right click on the hierarchy, 2D object, sprites, circle. It's going to be behind the map, so we're going to want to bring it up in a layer by 1. Move it over here for now. I'm going to change the color to more of an orange. You can do whatever color you want. And then in add component, we will do trail renderer. Bring the size down to about 0.4, and then click near the edge of the tail. Double click, and then drop it down to the 0. Give it a lifespan of about 0.5 seconds. Let's give this a new gradient texture. I'm going to do the same color, around the same color as the circle. And then, last thing we need to do is give it a materials, just default line. And now, we should be able to see when we're dragging it around, it will create a little trail behind it that will die over time. Let's then give it a 2D circle collider. And then we're going to turn this into a prefab by going to the hierarchy and dragging and dropping into the project menu. And there we have a prefab, just like that. Keep this organized. Let's go right click on assets, do create folder prefabs. That way we have our own folder that we can put the circle into. Now let's focus on how we can actually shoot this bullet by going back into our player script. To add shooting to this script, we're going to need to do a couple more global variables here. Let's start off with float shoot bullet, then a bool bullet cooldown, and then public float bullet fire rate. And we'll set that equal to 1.5 for now. And then public game object bullet prefab. And then a vector2 shot direction. And we'll set that to equal vector2 dot right. And the reason we have a shot direction is because we're going to be using the player's motion to determine what direction the bullet will be shot from. And now let's create our bullet script. For this, we're going to be using an IE numerator. And we'll call this fire shot 1. We'll set our bullet cooldown equal to true. And now we'll do the rest. We'll start creating our bullet. We'll do game object prefab to create a temporary variable. We will do instantiate bullet prefab, and then next line we'll do prefab.transform.position equal to the player's position. We will then do prefab.getComponent bullet, and then we will do move direction equal to shot dir. We'll then do yield return new, wait for seconds, bullet fire rate. It autofills for me. And then once we're done with that, we will then do bullet cooldown equals false to finish the shot for our thing. You'll notice here that I typed in bullet. That's for a script we'll be putting on the bullet later on. Now let's try calling this. What we'll do is we will do if shoot bullet does not equal 0 and there is no cooldown currently for bullet cooldown. We will then do a start coroutine fire shot 1. And to make this interactable with a key, we will do shoot bullet equals input dot get access raw, and then we'll set it to fire 1. And that should be enough. That should be what we need to do to create our bullet. Well, let's create our bullet script. Make sure to save. We'll then select the circle in scene, scroll down, add component, type out bullet, new script, yes, create and add. We can then go into Visual Studios. And in here we'll start by clearing out this for right now. And we'll add our public vector2 move direction that we added from the player script. We can then do public float speed, and let's set this equal to 5f. Let's then give this a public float death time, which is so that this bullet doesn't last forever if it doesn't hit anything. And then let's give it a public int damage that it will deal, and we'll set this equal to 1 for now. And now we'll create a start function where we'll then call destroy game object, and then we'll have it destroy the game object after this amount of time, which will be 2.5 seconds. We'll now add a fixed update function, which we will then do transform.translate, and then we will set this equal to move direction times speed times time.delta time. Make sure to save. Now back in the scene, we need to make sure we're applying these overrides onto the prefab. So click on overrides, apply all, and now when we start the game, we press play, we'll get an error. And that error is because we didn't actually put the prefab onto our bullet prefab player script. Now when we run it, when we press space, we'll get a bullet that goes in one direction. We don't want that to just be one direction, so we'll have to work on that. To fix this, we're going to open up the player script. Then we're going to do another if statement. And then we're going to do if motion does not equal vector2 dot 0. We will then set shot direction equal to new vector2 math f dot seal to int motion dot x, and then do the same mathf dot to seal int motion y, and this will set the direction based off our movement direction, and then the seal to int is setting it equal to 1, so we're not getting any crazy numbers. Don't forget to save, and now back into the game menu. If we do play game and we move around, we'll see that it will follow in our direction that we're walking in. To get the player to look in the direction that it's shooting from, we can go back into the player script, go to global variables, bool, direction, and then we can then make this into, we'll then set up a get, and then we will make this do a if statement, check shot dir dot x is greater than 0. We'll have it return false, and then else return true. Then right under our shot direction update, we'll do get component sprite renderer. Then we'll do dot flip x equal to direction. Now back in the game, we do this, press play, we move and we do that, and there we go. Our player now faces the direction it's shooting in. Real quick and simple. Now let's add it so that we can have our bullets interact with the enemy. We'll do this by going into circle. Make sure circle collider is set to isTrigger. Open the bullet script. Do a new function called on trigger enter 2D, and then we'll do an if statement, if collision dot get component, and then we'll just check to see if the collision has the enemy script on it. We'll then go and apply the damage to the enemy by doing collision dot get component enemy dot health minus equals damage, and then we'll do a destroy call on the bullet to get rid of it. And then since we don't have health on our enemy script just yet, we'll go back to our enemy script and add it real quick by doing public int health, and we'll set it equal to 2 for now. Make sure going back to the circle object and applying override so that the trigger object actually goes onto the bullet prefab. Last thing we need to do to make the bullet interact with the enemy is add a rigid body 2D to the enemy, and then make it so that gravity is equal to 0 because we don't want gravity involved here. Now, when we do this, it interacts with the enemy. Now let's have it so that when the enemy's health enters 0, it will destroy itself. So in this, we'll go into fixed update, do an if statement, if health is less than or equal to 0, we will have it destroy game object. Now, once we head back to the game, we will shoot twice and see the game object gets deleted, just like that. No more enemy. Just a little editor's note, I changed it so that they correspond to their names now. With that done, we can now start working on a spawner script. To do that, we'll need to go into the hierarchy, right click, create empty. We'll call this spawn manager, and then we'll do add component spawner, new script, create, and then once it's done loading, we'll now open it up in Visual Studio Code. For this, we're going to need 4 global variables. First one will be public float spawn time. Next one will be public int spawn offset. We'll set this equal to 1. Next will be a public game object. We'll make it into an array enemy list. And then finally we'll do a bool spawned, so we're not overlapping. We can get rid of the start function. In the update we'll do an if have not spawned. We will then spawn it. We'll then make spawned equal true so it's not repeating itself. And then we'll do an invoke method where we will invoke spawn enemy. And this will happen after spawn time. Now we just have to create the function for spawn enemy, which will be a private void spawn enemy. We will then do game object enemy equals instantiate enemy list. And we're just going to do 0 for now because we only have one enemy on the array. And then we'll set it up so that the enemies will spawn on the outside of the camera, but right next to it. To do this, we'll need to do a float camera height, set it equal to camera.main.orthographic size, and then we'll also have to do a float camera width, set this equal to camera height times camera main dot aspect. We'll now create an int variable, call it random direction, set it equal to random dot range, and we'll choose from 0 to 3. This is so that we can choose a direction that the enemy will spawn in. We'll now do a switch statement that will then go through the different options from random direction. For the first case, we'll do it so that it is going up, and we will set it so that enemy.transform.position equals new vector2, and then we will do camera.main.transform.position.x plus random.range. We will set it to be negative camera width to camera width. Then we will need to add camera.main.transform.position.y plus camera height plus random dot range 1 to spawn offset. And that will be what we need for that. And we can just type break for the next line. It's a big chunk of code, but we only have to really repeat it once, because now we can just do case 1. This will be down. We can copy the line we just did, put it here. All we have to change now is a plus sign to a minus sign at camera height, and also at the random range for camera height. Down the break, work on case 2. We'll have this one be right. Copy and paste. This time, we now have to change it so that all we have to do now is switch it so that instead of this, we will have plus camera width plus random dot range 1 spawn offset. And then do the same for the Y position, which is take this part out and then do plus random dot range camera height negative camera height to camera height. And we can just copy this one for the next case. Case 3, also case, which is just basically case 4. This would be left. Copy paste. And then instead of camera width plus camera width, it will then be minus camera width minus range. And then finally, to end this, what we have to do is break. And that's it for the spawn. And then last, all we have to do is at the end to wrap it all off is then spawn equals false. And then it will repeat the cycle. And that's it for the spawner. Back in Unity, we'll have to turn the enemy into a prefab. Then click on Spawn Manager, click and drag the enemy prefab onto enemy list. We'll give it a spawn time of 1 second, and then we'll increase the offset to 3. Then once we start the game, we'll see enemies start spawning on the edge of our screen and move towards us. So we now have a working game. Oop. We'll see that. We'll see that. To fix enemies from wiggling around like that, we'll have to go into the enemy prefab, constraints, freeze Z position, and that way they won't wobble around like that anymore. Alright, last thing we're going to need to do is add player health. To do this, we're going to need to do 2D capsule collider for the player model, and then into the player movement script, we'll need to add a bool health cooldown, and then a public int health, we'll set it equal to 3, and then a public float named health damage cooldown. And we'll set that equal to 1.5f. Down below our fire shot script, we'll add a new on trigger enter. Then we'll do an if statement checking if health cooldown is false and collision dot get component enemy script. We will then start a coroutine called health cooldown. We will then take the collision dot get component enemy tag dot damage. We can see that I forgot to add damage to the enemy, so real quick we'll go to the enemy tab and then type in public int damage. And we'll set it equal to 1. Back here in the player movement script, we'll now create the health cooldown, i.e. numerator. And in this prompt up here, we'll have to do int damage. Now here we will then call our health cooldown boolean, set it equal to false. Here's we named them the same thing, so hold on. We'll add timer to this. There we go. Now we will do health minus equals damage, and then yield, return new, wait for seconds, and then we will set it equal to health damage cooldown. Now we can do health cooldown equals true. Oops, I flipped them. So this actually is false, and this is true. Save, back into Unity. Don't forget in player capsule collider set is trigger true. And once we play the game, we'll run into them. You can see our health is going down over time. Finally, in our fixed update, we'll do one last if statement to check if health is less than or equal to 0. We will then do scene manager dot load scene. Then we will type scene manager dot get active scene dot name. Then once we die, it will just reload the game. You can see once our health goes to 0, the game will restart. With that done, we now have the base game completed. Everything else is just extra. So stick around if you want to see the extra bits, but otherwise everything's done. Start off with our extra bits. We don't actually need these prefabs in the game anymore, so we can just get rid of them. Then in the hierarchy, we can do right-click, UI, text, text message pro, import text message pro essentials. Back to scene view, press F on text to center onto it. We will align the text to be on the top, like that. We'll set the font size to 40. Give it a bold. We'll have it centered onto the screen. And then we'll give it a new component, call it clock. New script, add and create. Inside the clock script, we will delete this. And then we will create a new global variable, call it public tmp text, tmp underscore text. Call this underscore text. And then we'll do a float current time equals 0. And we'll use the update function. We will then write current time plus equals to time dot delta time. Then we'll use a new method called time span. We'll give it the name time, and we'll set it equal to time span dot from seconds. Use current time. We will then set our underscore text dot text equal to time dot minutes dot toString plus colon plus time dot seconds dot toString, and that will give us a time. And head back into Unity, scroll down to the script, grab your text and add it to the script. Now, in game, you'll see we'll have a working clock. And it looks a little weird right now, so the last thing I like to add back in our time clock script, we'll turn this to an if statement doing if time dot seconds is greater than 10, less than 10, we'll do text dot text equals to time dot minutes dot toString plus quote colon plus time dot time do seconds, and then at the colon we'll add a 0, and then we'll write else, and then we'll move the text up into the else statement. Now when we run the game, you'll see that it has the 0 where the 10-second is. Now we have a working clock in the game as well. Now you have a fully complete game. Congratulations.